Hello friends, today we are going to discuss about theory of automata, and this lecture covers the introductory part to the theory of automata. So today we will deal with certain topics, and topics are abstract machine, because before starting the theory of automata we have to deal with what is an abstract machine. Since in theory of automata our focus is about that abstract machine and what are designing logic behind that abstract machine. Okay? And secondly, the topic that we will cover, that topic will be formal languages and grammars. So before going further, we just start with what is an abstract machine. So in theory of automata, we deals with theory abstract machine, and abstract machine are those machines whose functionality, whose logical part is known to us. But if we talk about how that machine is going to be implemented, that is not known to us. Clear? So what we will focus about in theory of automata, we are focusing about the designing logic, how that machine works. Clear? So we will deal with those things, how that machine is going to work, or we could represent the same thing in a more detail by using a pictorial representation. So an abstract machine will be something like this. It's a box. It's a abstract machine. And we are knowing about, we are given some input to that machine. This machine is providing us certain output. Clear? And for this machine, we know how that machine works. That is logical. It's logic. So in theory of automata, we define that logic in mathematical notation, so that we could program that machine. We could establish some certain logical steps for that particular machine. Okay. So how could we do that? That's a very important question, and that need some description about how theory of automata is going to help us in designing that abstract machine. Okay. So for that particular purpose, we know that for every abstract machine there will be certain input. So obviously we will provide certain input to our machine, and this machine will work on that input and provide that output. Clear? So we are going to deal with about that logical part, how that logic can be designed, or how that logical steps can be established. Clear? So for that purpose, we are going to second step, that is formal languages and grammars. Since friends, we know that whenever we are designing our abstract machine, or whenever we are designing certain logic, then every logic can't exist without a grammar. Clear? Since suppose we want some logical part, like we want to accept a language that accepts only the integers. Clear? So how could we do that? Or for a time being, suppose we want to find the modulo of a given number. How could we find that? Clear? So for that purpose, we are going to deal about formal languages and formal grammars. So what is a formal language? A formal language is something that is different from a normal language. We know our language is known whenever we are communicating to each other, or whenever we want to explain our ideas or our views. But a formal language, since formal language is a thing that could be represented in a mathematical forms by using certain rules. Clear? So our formal language is different from your normal languages. Clear? And for defining those formal languages, we use certain grammar, because our language can't exist without a grammar. So for these formal languages, we are having the grammars. Clear? And these grammars is nothing but the set of rules that can be followed by a language if that language belongs to that category of grammar.